yeah, okay. I was like, wait a second.
I'm like,
Okay.
let's just get ready
Let's just jump right in and go. Okay.
and go. All right, welcome to Bias and Unbiased Point Estimates.
And we're going to try not to bring our personal biases to this. We're going to talk about bias and unbiased in statistics. And we all know that, there's lots of things that heavy words or heavy context in the world about political bias and cultural bias. And
Right.
That's not what we're talking about here, Jay.
Right.
We're talking about statistics that don't actually yield what we want.
Right. And so you really want to think about if I'm answering a survey, I could put my bias into my answer. That's one type of bias. Yeah. And then way earlier on in this course, we talked about if your grandma came to a high school party and what she would do to the mean.
Bring that back up.
And that is also a form of bias, right? That becomes a bias indicator because it changes based on who's at the party. You don't like this example.
I do not like that example. I don't know why, but all right. So what we're going to do is we want to try, when we're trying to do what we were doing last, remember we said we're going to take a sample of the whole population, and we want to do that in a way that is unbiased, that doesn't favor one aspect of the population. And again, people confuse that with human beings, but like if I'm surveying a plot of land, like the Christmas tree sample, I could pick up area of land that's very fertile and has yielded a lot of trees versus picking like the road that leads to it and wouldn't have trees on it. So bias and unbiased doesn't necessarily mean cultural or beliefs.
Right. So in terms of just numeracy, we say when estimating a population parameter, remember, as we think about this, like our statistic words are going to get heavier and heavier. Okay. So when estimating a population parameter, what does that mean, Mr. Bobby?
When we're trying to estimate like the mean or the proportion for the entire population, which we're never going to get, or actually be able to get, we're going to be estimating with a sample.
Yep. An estimator is unbiased if on average the value of the estimator is equal to the population parameter.
So I want to try to get close. So when we were talking about the last example, when we're trying to get a mean of the actual population was 75. When I take a sample, it should come out close to 75.
Right. Which means it's bias if what?
If it's not close to 70. So if I take a sample and I get like 90, I've chosen poorly.
Yes. Okay. That makes me think of Indiana Jones, where he
my gosh, you and I are the same human being. That's exactly what I was thinking of.
And he drinks it and he dies.
And then he dies. Yes. Okay.
Anyway, when estimating a population parameter, an estimator exhibits variability that can be modeled using probability.
They need to start watching old movies to understand the jokes.
My gray hair is showing.
Yep. They're like, Indiana Jones, what is that?
No, shut up. Okay, when estimating a population parameter, an estimator exhibits variability that can be modeled using probability. So what does that mean?
So I'm not going to get exactly the population mean, okay, but it should be predictable. I shouldn't get ones that are very, very far away. If I'm taking a good sample and doing it in a systematic, unbiased way, I should get close.
Right. Sample statistic. Sorry, go ahead. What?
As I say, I was going to get close. I'm not going to get exact, but I'm going to get close to the actual population proportion or mean or whatever it is I'm trying to measure.
Yeah. All right. A sample statistic is a point estimator. Now you're going to start hearing this a lot, okay? A point estimator of the corresponding population parameter.
So we've done it over and over. We did the 85, when we had 85 students, we took 30 samples. That's easy to do when we're talking about test scores or when we're talking about tree farms. But when we're talking about like a heavy duty medical experiment, the COVID-19 trials, for example, they didn't have a lot of time and they didn't have, even though they had a lot of money, they couldn't run the COVID-19 trials bunch and bunch of times. They had many, but they did it very quickly. So they didn't have as they would have done more if this wasn't such a pressing situation. What do you
So
got there?
right here is an article that my in-laws sent that says that this new um, words,
Seneca.
AstraZeneca, vaccine is up to 90% effective.
Yeah.
Where does the 90% come from? Well, it's a point estimator for the population of people that are going to potentially be taking this vaccine.
So there, it may actually be more or less secure than that, but they're saying that 90% of the people who receive their vaccine will develop immunity. And that's happened with, there's now, I guess that's the third one that's come out. And I know you guys are sick of hearing about it, but that's a real important example that we're all living right now.
Yeah.
And they couldn't run that trial. I mean, they had to do it quickly because people are really needing it.
Yeah.
So.
Yeah. And so just understand when we talk about a point estimator, because you're going to hear it a lot. The point estimator is from the sample statistic, but it's a generalization we're going to be making about the population parameter. Okay.
And
So
that's and to make one last tie-in, that's why they did big trials where they surveyed hundreds of people. When we were doing sampling in the last unit, we were taking samples of size 2 or 4 or 5. When we have samples of hundreds, that makes our standard deviation smaller and uses that point estimator, gets closer and should get closer and closer to the true mean or proportion.
So remember that my husband does research over here at UAMS, and they're actually running one of these COVID trials like this, and their goal is to get 20,000 people the shot, where it's actually 2 shots, before the end of the trials. 20,000 people at one location. Okay, so this is Janssen, which is Johnson & Johnson. I'm sure you guys have all heard of Johnson & Johnson, but their actual brand name is Janssen. Or they're not their brand name, but their research name is Janssen. And so think about one site, 20,000. How many sites do you think they have? You can't do a statistic or a sample statistic with a good point estimator without a big enough sample size from your population.
And they're trying to bring that variability down.
That's right. That's right.
And that's what we're talking about. What we're talking about here is the precision. The bigger the sample size, that smaller the variability. That's what we're calling precision. So we want to have it be precise. Now that's expensive. The government's funding that, but if they were doing it themselves, they wouldn't be doing 20,000 people. Okay, they'd be doing far less and maybe doing more trials. Yeah. So precision makes the data cluster. So we want that precision, but we also want to be fair. Okay, and that's what's happening in the upper left.
So we want precise and unbiased is what we want. Precise and unbiased. That hit the target. We shrunk our variability in and we hit the mark on our population mean or our population proportion, whatever it is we're looking at. Okay. Now, if we look at that left side, right, the precision is all about hitting the mark. We can hit the mark, but have a lot of variability in our data. That isn't great either. Now, it's good that we hit the mark, not great that there's so many marks all over the place. Okay. And look at that right side, right? Now we begin to talk about entering bias in. Okay. So we enter bias in, and now we've not hit the mark. So how important is bias when we start talking about this? Oh my gosh. Well, guys, if we end up with a bias point estimate, we might as well not have done the entire study.
Because we might be thinking the true value or the true mean proportions right there, and we're off. Okay, because you're gonna expect the variability. I would expect the mean or the true number to be right there. I'd expect the true value to be there, but it's so spread out that it might actually be bigger. Okay, I might think that it's that. I want to try to get what I think to have happened. The dots are what I think or what I'm gathering, and I'm going to make a decision based on those. Well, this guy over here, I'm going to think it's the real number is right there. So which of these, this one's not the worst case because I at least am in the ballpark, but these two, when I have bias, I'm thinking the number might be 95 when it might actually be 75.
Yeah, imagine the company is saying, oh, well, this is going to be 90% effective. And we give it to 10 million people. And turns out it was bias. It's
Yep.
only 60% effective. What?
So that a lot of people could be hurt by that. Okay, so bias is a big thing in statistics. We want to make sure that we're truly sampling the population in the best way we can, and we talked about that in experimental design. Okay, but our best case scenario is precision and unbiased or fairness. Okay?
So what creates the no bias? How do we create no bias? Well,
Well, go ahead.
No, go ahead.
I was going to say that's how we design our experimental design. We want to have true representation. In the last unit, we were talking about turkeys, and here we are, just a couple math teachers, middle-aged math teachers talking about turkey. We like turkey or we don't. I mean, Miss Young and I are not representative of all the people in this country.
Right. We generally say that the randomness, how random our design is how we get rid of any biases in them. Okay. There are all kinds of other things that go into this. And if you are truly super interested in statistics, which I kind of hope you are, and you go study about this, you will learn a lot about bias because it's such a big deal in statistics. But for now, we just want to make sure we understand, like, can we read a graph and do we recognize when bias happens within the graph? Okay. So let's look at this example. It says the histogram on the left shows the interval in minutes between eruptions of the Old Faithful geyser for all 222 recorded eruptions during a particular month. For this population, the median is 75 minutes. So we've just talked about the left-hand graph, which is the interval, what did I just say? The interval in minutes between eruptions. Okay, and there's 220 data points.
So this is the population.
Now, we use technology to take 500 simple random samples of size 10 from that 222 recorded eruptions. Okay? So we took 500 simple random samples of size 10 from the population. The 500 values of the sample medians are displayed in the histogram on the right. The mean of these 500 values is 73.5. So the question becomes, like, is this bias or unbiased? Later, okay? So let's look at a few things here. First thing I want to do is describe the shape of the sampling distribution of the sample median. So we're looking at that right green graph. Give me shape, Mr. Bobby.
It is skewed left. There's a tail on the left side. It's not symmetric. Sorry. It's just, you want shape.
Yes, just shape, right? So the shape is skewed left, and there's a single peak between 75 and 77.5. Okay. Good?
Yep, yeah.
Okay. Suppose we had taken samples of size 20 instead of size 10. So we increase the sample size to size 20. Would the variability of the sampling distribution of the sample medians be larger, smaller, or about the same?
It should get smaller. Remember, the larger the sample, the less variability. We saw that in the central limit theorem.
So we got variability decreasing. And then here's the important one, okay? Is the sample median an unbiased estimator of this population median? And this is a tricky question, okay? So you have to be careful here because you're gonna think, oh, median isn't heavily influenced by additional values. So is it biased or unbiased? Oh, well, median's always unbiased. Except, did we really read the question?
And these are the means that we got from our 5 sample. So we're taking a mean of a median, which is what threw me off the first time I saw this too. Yeah. So this is a big hard no.
Yeah, so let's go back to that concept of, if it's unbiased, what should happen?
It should cluster to the
true
value. Yeah.
Point estimate.
Yeah.
So the population median is 75 minutes. The median of the means is 73.5. Is it the same?
No, they're off by about 1.5.
Yeah, so if it's not the same, there's some bias there. So you have to be careful and keep coming back to, well, did it hold true? Right? So another way you can think about this, like if it holds true, our sampling would be about more approximately normal, okay? And our point estimate would match. But our point estimate of 73.5 is not the same as the true median, which is 75. And so we end up with like a biased answer or a biased point estimate. And there is a ton of ways this question is going to be asked of you. On a graph, like this, on a dot plot, could be asked in words. But the thought that you want to keep coming back to is, does it hit the target? If it doesn't hit the target, then it's bias. Okay.
All right.
So you got one assignment here, just a one Khan Academy assignment on bias versus unbiased estimators. I hope that makes sense. I hope you have a wonderful day, and we will see you next time. Bye.
Happy day. Bye-bye.